Now that we're getting a little bit more comfortable solving exponential equations, let's try example 3.14. This one has one step that often causes students to stumble a little bit. Please try the algebraic solution on your own first before we begin. I'll pause here to talk about this first part. Our first step is to rewrite 4, 8, and 16 using a common base of 2. Note that if the 8 wasn't there, we could actually write the 4 and the 16 using a common base of 4, but because of the 8, we'll need to go to 2. Now, at this stage, we have written each power and then multiplied the exponent inside the bracket by the binomial outside the bracket. The next step is the one that most often confuses students. Notice the right side of the equation. We have 2 to the power of 6x plus 6 multiplied by 2 to the power of 4x minus 12. This is a multiplication of two powers with the same base. Let's try to recall our exponent laws. If we had a to the x times a to the y, what operation would we perform on those exponents? When we multiply two powers with the same base, we must add their exponents. And so we add 6x plus 6 and 4x minus 12 to get 10x minus 6. At this point, we have 2 to the power of 2x minus 2 on the left and 2 to the power of 10x minus 6 on the right. And since the two powers are equal, we can say that the exponents must be equal. We then write 2x minus 2 equal to 10x minus 6 and proceed to solve for x. We find our answer of x equals 1/2. We can verify both the left and the right side of the equation by replacing our x with 1/2 or 0.5. In this case, both sides actually evaluate to give 0.5. We can also verify this graphically. Now, we can do this either by writing y1 as the left side of the equation and y2 as the right side of the equation and calculating the intersection point, or by graphing as y1 the left side of the equation subtracted by the right side of the equation, and then we would calculate the 0. The advantage of this method is the answer, if between -10 and +10, will always appear within the window automatically. If you had an intersection point that had occurred at a y value greater than 10 or less than -10, you might have to play around with your window a little bit. Regardless, both strategies are equally valid.